Okay, so once again, so our solutions were anything on that line. That's fine, but here's what we have to kind of shift our thinking so that today's a little bit easier. So how we're actually going to probably write this from here on out is, you know how we write usually x, y, can't I plug in, since this is infinite solutions, can't I plug in any x value? Yes. So I'm going to say I can plug in anything for x, but then if I plug in something for x, I get out something on the line, correct? My y's are dependent, meaning, yes, I can plug in anything for x, but then my answer will be on the line. So the y value is the line. So right here, y equals mx plus b. Do you see how that's in mx plus b form? Y is x plus 4. So do you see how I'm just writing x plus 4? Because we don't need to write y equals. This is in the y spot, so we're saying y equals x plus 4. Does that make sense? Okay. So, if we have two, what we were dealing with last time was if we had two variables. So if we were solving with two variables, then we would have two parts, like two equations. Today we're going to be doing three variables, x, y, z. So there has to be 1, 2, 3 equations. That's always true. So our solutions here we write as x comma y. So we just saw an example where we had a dependent solution, x and x plus 4, right? It was actually negative 4. Negative x plus 4. I forgot that it was negative x plus 4, sorry. Or we saw solutions like this, 1 comma 3, for example, right? If it intersected in 1 point. Or we saw no solution last time. So now our solutions today will just be written as an x, y, z point. So for example, if it was dependent, we might go like this, x, and then our y would be like, for example, negative x plus 4, and our z will be able to write as an x as well, so like x minus 2. Does that make, it doesn't make sense right now, but it will when we practice. It could also have just 1 point, 1 comma 3 comma 4, for example, or it could have no solution. So that's how we're going to see our answers written today. Alright, so here's our first example. Write it down. So when we solve systems with 3 variables, these are the steps we are always going to follow. If you follow these steps, it's going to make it so that every time you know where to start and where to go. Yes. Oh. Please label your steps. You know what was really frustrating for me is I've been telling people to do this, and then when I was walking around helping people with homework, I was like, where's your step 2? And their work was all jumbled together, and they couldn't tell me where step 2 is. The reason I'm telling you to do it like this is because it is going to make you do better and get less wrong. So just follow my lead here. Do what I do. So our first step we'll label as step 1. Now this is what we do for step 1, everybody. We're going to decide, looking at these 3, like x, y, z. We have to decide on a variable that we want to eliminate. So we can get rid of x, we can get rid of y or z, and it doesn't matter. So I wouldn't choose x. Here's why. They have a 2 and a 3 in front, a negative 3. Do you see how this has a 1, and a 2? That's smaller. So I would personally choose that one over x, but it wouldn't be wrong if you chose to get rid of x. Z would be not so bad either. So I'm going to write myself a note. We're going to eliminate y. So I write myself a note. I'm eliminating y. Now notice I wrote it twice. Here's why. We're going to pick 2 equations and put them together to eliminate y. And then we're going to pick 2 other equations, a combination of 2, and we're going to eliminate y in those 2 as well. So I'm going to look at this one. Look at the top and the middle. Do you guys see how the y's are opposites? Yeah. Let's put those 2 together because they'll cancel out really easily. So we would put x plus y plus z equals 0. The top and the middle, 2x minus y plus 3z's equals 17. Now we're also going to choose another combination of 2 equations. We've already done the top and middle, so now we need to pick another combination, either the top and bottom or the middle and bottom. So what would you prefer?
Top and bottom.
Top and bottom? See, well, and I was going to say I'd prefer middle and bottom because look, they're already opposites. Does that make sense? But it would be completely fine if you went with top and bottom. But I'm going to go with middle and bottom because they're already opposites. So then I'm writing in my middle one, 2x minus y plus 3z equals 17. And my bottom one, negative 3x plus 2y minus z equals negative 21. So now what you're going to do is eliminate that variable in both cases. So let's go back to this first piece here. We need to eliminate y. Well, isn't y already opposites? So we're going to just go ahead and add straight down. We didn't have to manipulate it, which is fine. It makes it easier. So add straight down. X plus 2x is 3x. Okay, good? The y's cancel out, don't they? Then z plus 3z plus 4z is equal to 0 plus 17. 17. Now look at our new equation. It only has x and z's. Okay, let's go over here. We're also eliminating y. We have to eliminate the same variable. We're trying to get down to where we only have two variables. So now look, we got to get these y's opposites. This one's negative and this one's positive 2y. So we need this to be negative 2y, so we're going to times the top by 2. So distribute and rewrite that equation. So we have 4x. Now we have minus 2y. Then we have plus 6z equals 34. Now add straight down and let's write what we get. Negative 3x plus 4x. 1x. And then our y's cancel out. Then negative 1z's plus 6z's, which is plus 5z's. And that's equal to 13 is right. Okay. Okay, so now look. We're done with step 1. So step 1 was, the point of step 1 was to get it so we have the variables, just two variables. Do you guys see how this is nice? Okay, so everybody, you label it step 2. Now what you're going to do is put those together. So put 3x plus 4z equals 17 and x plus 3z equals 13. And you're going to literally just start your brain over. You're going to say, well, I'm solving. Oh, is it 5z? Oh, I just can't. Okay, I see. Yes. 5z. Good point. Hey, now look. Isn't this like what we solved last time? Yes. So now it's literally just solving like we did last time. Start your brain over. Say, okay, I need to solve for x or z. Let's use elimination. Notice I used elimination. We're always going to use elimination. You could use substitution up here in step 1, but it's usually easier just to use elimination. Okay, let's stay consistent. All right, let's look here. You want to go get rid of x or z? Okay, now please write in your work. People were just doing it in their heads, and that's why they kept messing up. It makes me so sad. Shouldn't we probably multiply by negative 3 here? Okay, so I'm going to rewrite the top. So we have 3x plus 4z, keeping it the same. I'm just writing all my work nice and pretty. Now on bottom, I'm going to have negative 3x. I'm going to get negative 15z's is equal to, good, yeah, negative 39. Now we'll add straight down, so our x's cancel out. So we have negative 11z's equals negative 22. Well, look how nice this is. In step 2, we can now solve for z. So z is equal to positive 2. I'm going to circle it. Now in step 2 is literally doing everything we did in last time's homework. So now can't we go back and solve for x? Right, everyone? But it's really not, because this is exactly what we did last time, right? We just go plug it in right here or down here. So I'm going to plug it into the bottom one, floating a bulletin point. So we don't know x. So x plus 5, we do know z is 2, equals 13. So we have x plus 10 equals 13. So x equals 3. Circle that. So step 2 is just solving what we did last time completely. Now what we'll do is say, okay, we have x and z. All right, we're on to step 3. Find the other variable that you do not know. So you're going to go back to one of the very first originals and plug in what you know. So I'm going to go with the top one. X plus y plus z equals 0. Now we know two variables, so let's plug those in. My x is 3 plus y, we don't know y, plus z is 2 equals 0. Correct, everyone? So 5 plus y equals 0. So y equals negative 5. All right, so our final answer we write as an x, y, z point. My x was 3. My y was negative 5. And my z was 2. And we're done. Okay, let's pretend on the test you're like, I want to know if I'm right, or on the homework. What you could do is you could go back up here to the very, very original, and you know your x, y, z, and you could plug it in, and it would have to work here, and here, and here. If that's all a true statement, if you plug in the x, y, z here, and you get 0, you're good. Then you'd have to plug it in here, and if you get 17, you're good. Plug it in here, and if you get negative 21, you've done it right. Does that make sense? Okay, next one. All right, let's do another one. So we'll label our steps. Please label them for me, because it really helps when people say, I don't know what to do next. And then I say, well, look at step 2. And then they're like, well, I don't know what step 2 is. And I'm like, okay, that's it. That's how annoying it sounds to me. Yeah, because that's how annoying when somebody says that to me. Because I'm like, well, you should be doing work like I showed you. All right, so what you're going to do is choose a variable to eliminate. It does not matter which one. You're just going to pick one that's maybe going to make your elimination a little bit easier. So look, I'm looking at my x's, definitely not using x's because they're all so different. But my y's aren't bad, are they? And my z's are not too shabby. Do you want to do y or z? Really? I want to do z because look, those cancel out nice and easy. It's not that you would have been wrong, you would have been fine. You would have been fine. So let's go with z, just to be different. So now you're going to pick a combination of two equations, any combination of any two. So obviously if I want my z's to cancel out, I'm going to put this top one with this middle one first. It doesn't matter though, honestly. X plus y plus z equals negative 3, the top with the middle. 2x minus 2y minus z equals negative 7. Then you also do another combination of any two other equations. So you can't do the top and middle again. We've already done that. You could do the top and bottom or the middle and bottom. Yes, middle and bottom because they're already opposite signs. Not that it would have been wrong if you would have done it the other way. 2x minus 2y minus z equals negative 7 and negative 3x plus y plus 5z equals 5. Now eliminate the variable that you specified here. So look, we don't have to do any manipulation. We can add straight down and we're good. So we're going to get 3x's minus 1y. The z's are gone. That's equal to negative 10. Correct, everyone? All right, let's go over here. You are trying to eliminate z. Okay, good. Show that work and rewrite your problem. So I'm going to write it down here. So distributing, we get positive 10x's. We get negative 10y's. We get negative 5z's, and we get negative equal to negative 35. Okay, we're going to add straight down. So we get 7x's. We then get minus 9y's. True? Am I doing good? Yep. My z's cancel out, and we get equals negative 30. You've done step 1. Step 1 is the only reason we use step 1 is to get to step 2. So now step 2 allows us to put, we're going to put them together. So we have 3x minus y equals negative 10, and we have 7x minus 9y equals negative 30. In fact, even sectioning it off kind of helps to keep you focused in the right spot. Okay, so now you're just starting your brain over. You're saying, I just need to solve for x or y, like we did last time. So using elimination or substitution is fine, but I'll just do elimination. I'm going to stick to the same pattern. So should we get rid of y?
Yeah.
So we need it to be positive 9, so we're going to have to multiply by negative 9. True? Distribute, distribute, distribute. So we get negative 27x's. We get plus 9y's is equal to... That's okay. So we'll just be really careful as we're going, because right here, if you make an error, then the whole thing's wrong. But I've done it a million times. Like my key, I've caught a few answers that I did wrong. You just have to be super careful. So we get negative 20x's, right? My y's cancel out, and that's equal to 60. So now divide by negative 20, and we're going to know what x is. Good. X is equal to negative 3. Circle it. Now we're still in step 2. We're just solving for the other variable. So it looks like we're going to be solving for y. Plug it back into an original bulletin point. So we have a 3x, so that's 3 times negative 3, since we know x is negative 3, minus y equals negative 10. So we have negative 9 minus y equals negative 10. Adding 9 over, we'll have negative y equals negative 1, I believe. Yes, and then y equals 1. Circle that. Now what you're going to do, so let's, step 3, solve for the final variable. So look at a very original problem. So I could go look at the very top, but I can also see right here. An x plus a y plus a z equals negative 3. So let's plug it in. Where x is negative 3, plus my y is 1, plus we don't know z equals negative 3. Negative 2 plus z equals negative 3. Add 2. Therefore, z is equal to negative 1, right? All right. We have an x, y, z point, which came out to be x was negative 3, y was positive 1, and z was negative 1. Yay! Whoa.
There's like one that took up like a page and a half and worked for one person.
There's probably a few that did that. Okay, let's do another one. Okay, I'm only actually going to do 3 more examples. This one's going to be an example where you see no solution, and then we're going to do 2 with infinite solutions because they're just a little bit harder to write. So here we go. Somebody give me a second to write it down. Yes. Okay, here we go. So, step 1. Choose a variable to eliminate. How about z? Okay, z, sure. Fine with me. So, I'm going to do the top. X plus 2y minus z in the middle, or equals 4 in the middle. Negative 2x plus 3y plus z equals negative 4. Then I'm going to do the middle and bottom. Negative 2x plus 3y plus z equals negative 4, and the bottom. X plus 9y minus 2z's equals 1. And let's start eliminating appropriately here. So z's are going to cancel out automatically, so let's add straight down. So we get negative x plus 5y's equals 0. Correct. Alright, we're doing z. This needs to be positive 2. So we need to multiply by 2, giving me negative 4x plus 6y's, because I'm distributing, plus 2z's, and then it looks like equals negative 8. Add straight down. Negative 3x's plus 14, right? 15y's minus the z's are gone, and that's equal to negative 7. Alright, we're on to step 2. Label step 2. Section it off. Step 2, putting them together. Negative x plus 5y equals 0. Negative 3x plus 15y equals negative 7. Okay, let's eliminate. X or y? Right, we're solving. Like starting your brain over, we're eliminating. Okay, so we're going to multiply by negative 3 because you decided to get rid of x. So let's distribute, so then we'd get positive 3x minus 15y's, and looks like equals 0. Now let's add straight down. 0, plus 0 equals negative 7. Does 0 equal negative 7? Remember, so this is a problem from last time. When this happens, there was no solution, correct? Well, if there's no solution for this part, then there can't be a solution for all of it. So no solution. And we're done.
Is there a point where like this has a solution and then you go through it and it doesn't have a solution on the 3rd step? Or
No. No. Yeah. Okay, here we go. Now this is the one where it's going to have infinite solutions, turns out. You're going to see. And writing the answer is the hardest part for people. You've got to focus on this one. So make sure the weight and highlight between steps or just weights. Okay, so here we go. Which variable should we eliminate? It doesn't matter. Okay.
No, wait.
Let's get rid of Z.
Okay. Changing your mind. Okay, let's go Z. So labeling your steps. So top x minus 3y minus z equals 4 with the bottom, right? 2x minus 5y plus z equals 9. Let's just go for it right here, and then we'll put 2 together and go for it. So let's add straight down, because you said z, and z's will automatically cancel out. So we're going to have 3x's minus 8y's equals 13. Awesome. Okay, another 2 equations let's put together. So how about
Yep.
top and, so you're saying do top and middle?
And then multiply by 2.
Okay.
So that we can cancel the x's.
Oh, we actually have to do the same variable.
Oh, yeah.
Yeah, you're okay, you're okay. But that's, yeah, it's a good, that's why we write, but you're right, it's, okay. So, x minus 2y plus 2z's equals 5. So we, once again, we're eliminating z, so we need it to be negative 2z's. So we'll times by positive 2, since it's already negative. Distributing to all that, so we would get 2x's minus 6y's minus 2z's. That's equal to 8. Then we're going to add straight down. And then we're done with step 1. 3x's minus 8y's. The z's are gone, equals 13. And we're done with step 1. So step 2. Now they won't always be this obvious, so we're going to pretend like they're not so obvious. So we have 3x minus 8y equals 13, and we have 3x minus 8y equals 13. So they won't always be this obvious. They're the same, right? They're the same equations. So we can, it's going to be infinite solutions. We can plug in anything, but they won't always be this obvious. Let's pretend like they weren't. We would eliminate a variable. So let's pretend like they weren't. Let's times all of this by negative 1 and get rid of x, for example. Negative 3x plus 8y equals negative 13. Because I'm distributing. And then add straight down. 0 plus 0 equals 0. Does 0 equal 0? Yes. So that's infinite. So right. Now remember though, we can't just write infinite. Yeah, there might be infinite x's, but doesn't it have to be an answer on the line?
No, it has to infinite x line.
Well, it's more complicated than that, right? Because it's a specific line, right? It's a specific line. So we'd say, okay, my answer is going to be some x, y, z, and we are here. So we have x and y's. So do you want to keep x? Do you want to start with saying x can be anything? So we can plug in anything for x, but then y will be. So don't we need it to be y equals mx plus b form? Because we're trying to say, what's y equal to? Well, it's equal to the line. So get it in y equals mx plus b form. I'm going to change colors here. So starting with 3x minus 8y equals 13. Get it in y equals mx plus b form. Here we go. Subtract 3x. So we have negative 8y's is equal to negative 3x. I write mx first plus b. So plus 13. Divide by negative 8. So y equals, let's split this up because that's how we write lines, mx. So a negative and a negative become a positive. So we have 3/8 x. True? Then positive divided by negative is a negative. So minus 13/8. So our y is that. So instead of writing y, we write that. 3/8 x minus 13/8. And now we're going to plug in, we need z now. So now we're on to step 3. Everyone label step 3. Because it's still the same idea, still the same thing. So let's label step 3. I'm erasing because I won't want to scroll down any further because my answers are right here and I want to keep them here. Okay, can anyone remember, tell me, so we're on step 3 now. Tell me an original equation, one that doesn't have a...
X minus 3y minus c equals
Okay, aren't we trying to get z equals x, y? We're saying what's z? So we need it to be z equals. So get it to be z equals. So subtract x, add 3y. Subtract x, add 3y. So we have negative z is equal to 4 minus x plus 3y. Get z alone. Divide by negative 1. Isn't that the same thing as timesing by negative 1? So z is equal to negative 4 plus x minus 3y. Now we cannot insert it yet because didn't we say that we have to have, we know what y is. Isn't y this? So we can't use y. We have to use that because it's very specific. Y is that. So the z has to be with x. So basically we're substituting this in. X stays as x. Y has to be substituted in. So we have z is equal to negative 4 plus x minus 3. And then our y is 3/8 x minus 13/8. So honestly guys, the hardest part is literally just being able to do basic algebra, which algebra's hard for people. In fact, most people fail calculus 1 because of their algebra, not because of calculus. So let's look into simplifying this. That little tail is bugging. Okay, we gotta combine like terms and simplify this down here. So we need to distribute this negative 3 through. Now remember, how do we multiply fractions? Straight across. So we still have z is equal to negative 4 plus x. We're distributing negative 3 over 1 times that. So negative 3 times positive 3 is negative 9, correct? 1 times 8 is 8, so negative 9/8 x. Negative 3 times negative 13 is positive 39. 1 times 8 is 8. We can't stop there because we have to combine like terms. Numbers can be added with numbers, x's can be added with x's. So we have z is equal to, aren't we going to be adding up negative 4 plus 39/8? And then we're also going to be doing plus 1x minus 9/8 x. Okay, we need to get a common denominator and put these together. Now why do we have to do it by hand? Because our calculator doesn't have the math enter thing. So we got this. So we have negative 4 over 1 plus 39 over 8. Is everyone watching very carefully? I need a common denominator. So I'm going to multiply by 8 over 8. So that becomes negative 32 over 8 plus 39 over 8, which is, yep, and we don't add the bottoms, right? We get a common denominator so we can add the numerator. So that's 7 over 8. Not that bad, guys. Now I'm also going to combine 1 minus 9/8. And they're x's obviously, but we're just combining the number part. So that's 1 over 1. But I need a common denominator. Times by 8 times by 8. So that's 8/8 minus 9/8, which is, yep, negative 1/8 x. So actually z, we're done. Z is equal to negative 1/8 x plus 7/8. And now we are all happy because we're done. So here we go. Writing it in. So then negative 1/8 x plus 7/8. Now look, one thing you have to notice is your final answer for infinite should have all of the same variable. So x, x, x. So we've done this right. Okay, let's do another one. Okay guys, I'm telling you right now, I want you to, we're going to eliminate x. Because you guessed, here's why. Just because. Okay. I have to say why, and I'm like, wait, I'm not even going to get what the heck. Okay. Let's just eliminate x. I'm doing it for a reason. Okay, here we go. So eliminate x. Let's just eliminate x. So x minus y plus 3z equals 2. Negative x plus 2y minus 5z equals negative 3. And we are going to add straight down, eliminating x. y minus 2z's equals negative 1. Uh-oh. Okay, then let's do the middle. No, wait, we're eliminating it. Yeah, middle and bottom. So we need to do some manipulation on this bad boy. So we're going to multiply all this stuff by 2. Ding, 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 ding. So we get negative 2x plus 4y's minus 10z's equals negative 6. Adding straight down. X is gone. 3y's minus 6z's equals negative 3. And labeling your word. So I'm going to go like this, step 2, and cutting it off. So now put them together. Y minus 2z equals negative 1. 3y minus 6z's equals negative 3. And your brain is starting over. I'm eliminating a variable. Which one would you like to eliminate?
Y.
All right.
Would we be okay to simplify the second equation since they're all three? Okay.
Because you'd be dividing it out.
If we have to have it outside of the thing.
Which you'd be factoring it out. Yeah. So then, yes. Good point. Okay, so we're going to times everything by negative 3. Distribute, distribute, distribute. So we have negative 3y's plus 6z's equals 3. Now add straight down. 0 plus 0 equals 0. So 0 equals 0, so we have an infinite number of solutions. Now stay in step 2. This is where everybody gets confused. They go, now what do I do next? Stay in step 2 in your brain, because this is what we would have done last time. This is exactly how we would do if we just had 2 equations. We'd say, okay, so we have an x, y, z, right, everyone? Now look back here, though. We are not going to be able to solve for x, because look, we have y's and z's. That's okay. So you're going to choose. Do you want z to stay z? Is z to be the one we plug anything into, but then y will depend on what we get out? You want to put z? And we could do y. Yeah, good point. So she's saying if we did y, we could just add 2z. Does that make sense, everyone? Either one equally fine. So let's go with y randomly. So I'm going to put in my y. We can plug anything into. And then now we need to solve in terms of, we need to know what x is, we need to know what z is. So we need it to be z equals actually though, don't we? But that's okay, let's keep going with it. Do you see how we need to actually have it z equals?
Wait, no, okay.
Because look, I'm saying z is what? Do you see how that helps you know that you have to actually solve for z?
Oh, really?
Okay, so solve for z. So we will subtract y. I'm going to make a little bulletin point. I like to keep this part nice and pretty too. So subtract y. So I have down here, negative 2z's is equal to negative y minus 1. Getting z alone. Divide by negative 2. Divide by negative 2. So z is equal to positive 1/2 y. Watch out for those signs. And then plus 1/2. So now we can insert that in. Instead of z, we're actually dealing with 1/2 y plus 1/2. And now we can section it off and do step number 3. So an original equation, anyone remember one?
X minus y plus 3z.
Okay, let's plug in what we know. No, actually, let's not plug in what we know yet. Let's solve for x first, because don't we not know what x is? So let's get x alone here, because we want it to be x equals something. So add y, subtract 3z. Add y, subtract 3z. So x is equal to 2 plus 3z. I forgot to write, wait. What did I do? Why did I write something weird?
I don't know.
Okay, wait. So it was just equals 2, right? So I added y minus 3z. So we have 2. Sorry, my bad. We were right here, so everyone's not confused. Okay, look. We were here. Is this a true statement?
Yes.
Solve for x. Add y, subtract 3z. Add y, subtract 3z. So we have x is equal to 2 plus y plus minus 3z. Okay. Now, looking back at your answers so far, they all are y's, correct? Freaking A. Okay, back to our point. Are they all y's? So your answer can only have y's in it. So this y's okay. But this z is not. So we have x is equal to 2 plus y minus 3. What was z?
1/2 y.
1/2 y plus 1/2. Now we need to just simplify it. Then you're going to take a deep breath and say, I'm literally just doing like 4th grade math. It's going to be okay. So we have x is equal to 2 plus y, and then we have distribute that there, distributing straight across, so minus 3/2 y, correct? And then negative 3 over 1 times 1 over 2 is negative 3/2, correct? So we have x is equal to 2 minus 3/2 plus 1y minus 3/2 y. So now we need to do our fractions again. And once again, keeping a positive mindset. So I'm just putting the things that are liked by each other. So then saying, okay, I can add fractions. That's 2 over 1 minus 3 over 2. I need a common denominator. So I need to multiply by 2 over 2, which would be 4 over 2 minus 3 over 2. Therefore, I can combine the numerator, which is 1 over 2. So we have x is equal to 1/2 for that. Now we're going to say, okay, so we're adding 1 minus 3/2. Isn't this 1 over 1? And we're going to times by 2 and 2. So then we have 2 over 2 minus 3 over 2, which is negative 1 over 2. And that was in y. That was a y. So then we have minus 1 over 2y. So probably we should write it like this. X is equal to negative 1/2 y plus 1/2. And we'll go back up and insert that in. Or is it backwards?
It's negative 1/2 y plus.
Yeah, negative 1/2 y.
So then negative 1/2 y plus 1/2. And then you'd say, do I have all the same variable? Yes, so I'm all good.